Hello students, in this class we are going to learn about functions, relations and functions. So we'll start from the beginning. So first of all, we'll learn what is Cartesian product of sets. If there are two sets A and B, set A is having two elements P1 and P2 and set B is having three elements S1, S2 and S3. Then if we'll take the Cartesian product of set A with set B, means A cross B, what will be the elements in this set? So that we are going to see. See, set A is having two elements P1 and P2. Set B is having three elements S1, S2 and S3. If we are taking Cartesian product of set A with B, then the elements in the set A cross B will be P1, S1, P2, P1, S2, P1, S3. So three elements. When we will take the Cartesian product of this first element with S1, S2 and S3, this will become P1, S1, P1, S2 and P1, S3. Correct? Now you will take the Cartesian product for the second element. So for the second elements means we will take the product of P2 with P2 S1, P2 S2 and then P2 S3. Correct? There are P2 S1, P2 S2 and P2 S3. So these are the ordered pairs in the set of A cross B, means Cartesian product of two sets A and B. So this is the definition of Cartesian product of sets. Given two non-empty sets A and B, means here A and B, none of these sets are empty. The Cartesian product A cross B is the set of all ordered pairs of elements from A and B. Elements from A and B, because we are taking Cartesian product from A and B. Correct? So this will be AB, where A is a member of capital A, set A, and B is a member of set B. Come, now we are going to learn it from some example. See, there is a set A and set B. This is set 1 A, set B. The element of set A are 1 and 2, means set A is having two elements 1 and 2. Set B is having three elements A, B, C. So now when we'll take the Cartesian product from A to B, from A and B, means A cross B, then what we'll do? A 1 A, this will be one element. 1 B will be second element. 1 C will be the third element. Correct? So 1 A, 1 B and 1 C. Similarly, for 2 also we'll take 2 A, 2 B and 2 C. This is 2A, 2B, 2C. Now see here how many number of ordered pairs are there? 1, 2, 3, 4, 5, 6. What is the number of elements in set A? Means number of elements in set A is equal to how much? 2. What is the number of elements in set B? Is 3. Then the number of elements in Cartesian product of A and B will be 2 into 3. That is 6. Correct? So in this way, we can find the Cartesian product of one set with other, and also we can know how, what will be the number of elements. If I means we are taking the Cartesian product of two sets A and B. If either A or B is empty, means either A or B is an empty set, then what will happen? A cross will be an empty set. That is also called null set. If A or B, either of the two is an empty set, then the Cartesian product of A cross B will be an empty set or null set. Empty set. If A and B are non-empty sets, and either A or B is an infinite set, then so is A cross B. Means here A or B, either of the two sets were empty set, so result was empty set. Here either of the two sets A or B is an infinite set, then the result will also be infinite. Then it will also be infinite set. Means A cross B will be infinite set. Third point, two ordered pairs are equal. Two ordered pairs are equal if and only if the corresponding first elements are equal and the second elements are also equal. If the corresponding first element and second elements are equal, then only two ordered pairs will be equal. See, this is an example. It is already given. This is ordered pair A minus 3, B plus 2. Means the first element of this ordered pair is A minus 3, second element is B plus 2, which is equal to 4 minus 2. Find the values of A and B. So from this, it means if this has to be equal, it means A minus 3 should be equal to 4. And B plus 2 should be equal to minus 2. Isn't it? So when A minus 3 is equal to 4 and B plus 2 is equal to minus 2, when we will solve it, we'll get A is equal to 4 plus 3, that is 7, and B is equal to minus 2, that is minus 4. This we have already seen. If number of elements in set A is equal to P and number of elements in set B is equal to Q, then number of elements in the set A cross B will be P into Q. We have already seen if the number of elements in set A is equal to 2 and number of elements in set B is equal to 3, then number of elements in Cartesian product of set A and B will be 2 into 3, that is 6. Okay. Now there is a relation. A cross B intersection C is equal to A cross B intersection A cross C. It is just like the distributive law. Means A into B plus C. What we do? Is equal to A into B plus A into C. This relation is similar to this. Correct? And if A, we are taking the Cartesian product of two sets. First set is A, second set is B union C. In that case, the result will be A cross B union A cross C. This also we can compare from this. A, B minus C. What happens? A cross B minus A cross C. Correct? So just this only I am telling for the similarity, because this is similar. So this is not changing. This is not changing. This will remain same. Yeah, so this will remain same. Here we are going to prove. See, there is a question. If P is equal to AB and Q is equal to XY, means if P is a set whose members are A and B, Q is a set whose members are X and Y, then find P cross Q and Q cross P, and we have to see that are these two products equal? So first of all, we'll find P cross Q. So P cross Q means A cross A. First member will be AX, second member will be AY, third element will be BX and BY. AX, AY, BX, BY. Now we are taking Q cross P. Q cross P means Q is equal to XY and P is equal to AB. So here the elements of the Cartesian product Q with P will be XA, XB, YA and YB. XA, XB, YA, YB. So what we see here, AX is not equal to XA. AX is not equal to XA because because here the elements are not in the first element should be equal to the first element, corresponding first element. The second element should be the equal to the second element, but here it is not. Means AX is not equal to XA. That is why it is called ordered pairs. Correct? If it is like this, AX and this is also AX, then we can say this is equal. But here it is not. Here it is AX and the first element of Cartesian product of Q with P is XA. So they are not equal. So what we are finding, it means therefore P cross Q is not equal to Q cross P. Now we have to prove, let A is equal to 1, 2, B is equal to 3, 4, and C is equal to 4, 5. Verify that A cross B intersection C is equal to A cross B intersection A cross C. Solution, what we'll find it? First of all, we'll find this one. A cross B intersection C. So first of all, we'll find the B intersection C. What we'll get here? B intersection means C means what? The elements which are common to B and C both. So this will be 4. Correct? 4 is common here. Here also it is 4. Here also is 4. So now this is one set, and this is A is what? 1, 2. So 1, 2, A is equal to 1, 2, and B intersection C is equal to 4. So what will the element? If you will take A cross B intersection C, elements will be 1, 4 and 2, 4, isn't it? 1, 4 and 2, 4. So we have just now we have found the left hand side. Now we'll find the right hand side. So here first of all we'll find A cross B, Cartesian product of A with B. So this is 1, 3, 1, 4, 2, 3, 2, 4. 1, 3, 1, 4, 2, 3, 2, 4. Now for B cross C, 3, 4, 3, 5, 4, 4, 4, 5. But here you have to check for the we need not have to do B cross C. We have to check for A cross C. So we'll do A means 1, 3, 1, 4, 2, 3, 2, 4, and then for A cross C 1, 4, 1, 5, 2, 4, 2, 5. 1, 4, 1, 5, 2, 4, 2, 5. Now see, we have to take the intersection of these two sets. Means the elements which are common in both. So what is common here? 1, 4, 1, 4, and then 2, 4, 2, 4. So A cross B intersection A cross C is 1, 4, 2, 4. See, and this is the same. It means this and this both are equal. So it is proved. Correct? So hence from 1 and 2 we get A cross B intersection C is equal to A cross B intersection A cross C. Now we are coming to now we are familiar with the ordered pairs. The properties of ordered pairs. Now relations. So similarly, if there are two sets A and B, then these two sets A and B, how many elements it can have? It can have, see, there are two elements in set A, means NA is equal to 2. Number of elements in set B is equal to How many? 4. So number of elements in set A cross B will be 2 into 4, that is 8. So if you want to write the complete set of A cross B, I'm writing here. See here. So this will be A Ali, then A Babu, then A Bindu, then A Clara, then B Ali, then B Babu, then B Bindu, and then last element will be B Clara. Now count the numbers. How many numbers are there? One. How many numbers of elements are here? 1, 2, 3, 4, 5, 6, 7, 8. Here also we are getting 8. Correct. So there are 8 elements in the Cartesian product of A and B. Now we are defining a relation. Relation means we are establishing a relation from set A to set B. Means we are taking the first letter of the name. So first letter of the name of these 4 persons. So in the set A, what is the first means here the first name is Ali. So what is the first letter, first alphabet? A. Here for Babu and Bindu it is B. First letter is B. For C there is no any element here. Okay. So it means the relation only we can relate this A with Ali, B with Babu, and B with Bindu. So how many elements and what will be the elements of this relation? Elements of this relation from A to B will be A Ali, B Babu, and B Bindu. And what we see here A Ali is already a member of this. A Ali is already there. A Ali. And B Babu is also there. B Babu and B Bindu. Means this relation is a part of this Cartesian product. This relation is a part of this Cartesian product. So if there are 2 sets and we are taking the Cartesian product of 2 sets, then we are able to find the ordered pairs, and the number of ordered pairs in this case it is 8. If so, so whatever relation we are defining, it means the maximum number of elements in a relation can be 8. Now this single can also be a relation. These 2 can also be relation. So in this way we can make so many relations. Here we are defining our relation as we have to take the first letter of the name of the members of set B. So that is why we are defining A with Ali, B Babu, B Bindu. Similarly, there are n number of relations we can define. So how many relations we can form? So that also we can see. So see here, if number of elements in set A is equal to P, number of elements in set B is equal to Q, then number of elements in Cartesian product of A from B will be PQ. Okay, this is the number of elements in the Cartesian product of A and B, and the total number of relations from A to B is equal to how many? 2 to the power PQ. 2 to the power PQ. So these many relations we can form. So in our case, see here. In our case, we are finding if this is P, this is Q, this is your P into Q, PQ. is equal to 8. So here the total number of relations that can be formed from these two sets is equal to 2 to the power pq, means 2 to the power 8. These many relations we can form. Correct? Now we'll come to the function. Okay, so there are two terms, relations and functions. So all functions are relations. All functions are relations, but all relations are not functions. Okay, all functions are relations, but all relations are not functions, and that we are going to see in our next class, in next lecture. Okay, in detail we'll see if there are so many relations, then what are the conditions for a relation to be a function. Okay, that we'll see in the next class. So today we'll stop here and we'll meet in the next class, and one by one we'll do all the parts of function, then limits, then continuity, then differentiation, integration, everything we are going to do one by one.